We constantly guess what the future will look like, but we rarely ask how it will be funded. Let's run the numbers. Consider a future where delivery drones crowd the sky. If we assume that dense swarms of autonomous delivery drones fill our skies, we might expect a massive boost in logistics efficiency. However, this scenario also creates a severe coordination problem. Under this assumption, thousands of private aircraft cross the low-altitude sky daily to drop off goods. This constant activity imposes negative externalities such as noise, safety hazards, and local privacy risks. Interestingly, local residents bear the physical costs of these flights despite having no direct role in the transaction. This mismatch represents a classic market failure where third parties absorb private costs. We must analyze how economic incentives align when the sky becomes a contested pathway. Flight technology might improve, but the scarcity of quiet, secure airspace above our homes remains a constraint. So, who actually controls the rights to the sky above your roof, and who pays for the disturbance? The answer depends less on engineering than on the design of property rights. As autonomous drone swarms multiply, we identify the binding scarcity. The primary bottleneck is not the speed of the aircraft, but the finite carrying capacity of the low-altitude residential airspace corridors. When a delivery company operates a flight, it consumes airspace capacity and generates noise. This strategic action is rivalrous because multiple aircraft cannot safely occupy the exact same spatial coordinates simultaneously. Here is the constraint: we cannot simply ignore the local residents who live underneath these routes. The noise and vibration impose real, measurable costs on every household in the flight path. The observable consequence of this negative externality is intense local resistance. Without a clear mechanism to resolve these disputes, residents may lobby for strict municipal bans, freezing all flight operations entirely. Follow the incentive structure. If drone operators can fly over homes for free, they would tend to over-allocate flights, creating severe congestion and noise pollution until the local system faces collapse. This misallocation could alter the distribution of local property values. Neighborhoods subjected to constant low-altitude flight corridors face severe depreciation, while quiet zones capture an economic premium in this speculative scenario. To analyze this scenario, we must define negative externalities. In standard economics, an externality occurs when a transaction between two private parties imposes uncompensated costs or benefits on a third party. Under this assumption, the drone company only calculates its fuel, equipment, and maintenance costs. The operator completely ignores the constant noise and local disruption suffered by the quiet residents living below. Historically, economists proposed taxing the polluter to correct this divergence between private and social costs. However, determining the correct tax rate requires private information that central regulators rarely possess in practice. Alternatively, the Coase Theorem suggests that private bargaining could resolve externalities efficiently. If property rights are clearly defined and transaction costs are near zero, parties would tend to negotiate optimal outcomes. Under this assumption, it does not matter who initially receives the property rights. If the resident owns the local airspace, the drone company would pay them for the right to fly. Conversely, if the drone company owns the flight rights, the resident could pay them to redirect the flight path. Either way, the airspace would be allocated to its highest value economic use. This elegant bargaining solution assumes that the cost of negotiating is completely non-existent. However, in this speculative future, the assumption of zero transaction costs is the first key thing to fail. We must define transaction costs as the time, effort, and financial expense required to make any economic exchange. These costs include finding transaction participants, drafting contracts, and enforcing the final agreement. Under this assumption, low-altitude flights would generate high transaction costs because they affect thousands of individual homeowners. Negotiating a separate private agreement with every resident along a route is completely impractical. It comes down to scarcity. When physical airspace is abundant, transaction costs are low because interactions are rare. But dense drone traffic makes coordination costs the binding scarcity in the economy. Without a cheap bargaining mechanism, the coercion solution breaks down. Drone companies cannot negotiate with 10,000 residents, and residents cannot easily coordinate to buy out the operator's specific flight path. Consider the legal foundation of low-altitude airspace. Historically, property owners held rights to the sky above their land indefinitely under the ad coelum doctrine, extending high to the edge of space. This absolute doctrine was modified in the 20th century to allow high-altitude commercial aviation. The public highway of the sky was established, leaving only the immediate low-altitude airspace to local landowners. But the low-altitude zone remains legally ambiguous. In this speculative scenario, the boundary between private property and public transit is contested daily as drones fly only meters above local residential rooftops. If we define airspace rights as private, drone companies face massive trespass liabilities. The threat of legal action forces them to negotiate, but high transaction costs prevent these negotiations from succeeding. Conversely, if we define airspace rights as public, residents suffer the negative externalities lacking any compensation. The drone companies free ride on the quietude of neighborhoods, eroding the local quality of life. This imbalance triggers defensive investments. Local residents might install signal jammers or physical nets to protect their homes, creating a wasteful and highly inefficient security conflict in the entire local community. To evaluate this model, we must establish its boundaries. The coordination bottleneck only binds if the total number of affected parties is high, preventing cheap collective bargaining from occurring in practice. For instance, in a rural farming region, a drone route only crosses a few large properties. Here, transaction costs are low, and the Coase Theorem predicts a successful private bargaining outcome. Additionally, an alternative equilibrium could emerge if drone routes are restricted to existing public highways. By consolidating flights over busy roads, operators could minimize the negative externalities imposed on private residents. However, this highway consolidation assumes that public roads can accommodate all delivery traffic. In practice, narrowing routes to highways creates severe aerial congestion and delays, limiting the maximum overall delivery capacity. We must also note the physical limitations of the technology. Noise reduction can decrease the externality but cannot fully eliminate it. The physical presence of moving aircraft tends to impose risk. A validating case is found in the history of airport noise disputes. Because individual negotiations failed, airports resorted to rigid flight curfews and zoning laws, demonstrating the breakdown of coalition bargaining. This brings us back to our opening question of airspace ownership. The answer is that neither private nor public extremes can resolve the externality efficiently when transaction costs remain prohibitively high. The consequence of this breakdown is market thinness or outright closure. Drone companies cannot secure reliable routes, and homeowners face constant ongoing noise pollution, leading to mutual frustration and economic waste. Change the assumption, change the equilibrium. If we establish a digital transaction platform, we could theoretically pool airspace rights, allowing automated micropayments to compensate homeowners for every single low-altitude flight. Under this assumption, smart contracts would distribute compensation automatically based on flight path coordinates. This mechanism would lower transaction costs to near zero, reactivating the coalition bargaining process in urban neighborhoods. However, implementing this digital clearinghouse would require complete consensus on the value of quiet airspace. We cannot easily quantify the subjective cost of noise for every individual resident in the city. Until we resolve these measurement difficulties, the transaction bottleneck remains binding. The practical resolution is that flight routing would tend to be decided by administrative zoning rather than private Coasean bargains. This reality forces us to reevaluate the promise of drone logistics. The primary constraint is not flight duration or payload capacity, but the institutional design of local low-altitude airspace property rights. By recognizing this bottleneck, we can avoid the mistake of funding technology without property institutions. True efficiency would require managing the legal sky alongside the physical aircraft in our modern cities. The core mechanism of this transition begins with the allocation of flight paths. Because airspace is non-excludable under current public transit rules, drone operators naturally treat it as a free input. This treatment of airspace as a free resource moves the supply curve of deliveries outward, creating a potential consumer surplus. However, it shifts the unpriced noise costs onto property owners below. Follow the incentive structure. If airspace rights are undefined, operators would tend to maximize flights, creating congestion. They have little incentive to invest in quiet technology because they bear no externality costs. The resulting noise pollution causes high local resistance, leading to municipal bans. Operators cannot project route stability, which reduces their long-term capital investment in autonomous delivery networks in these areas. Change the assumption, change the equilibrium. If we establish a municipal bidding system, we could theoretically sell low-altitude corridors to drone operators, using that revenue to compensate the affected neighborhoods directly. So, in this scenario, the price of flights would reflect their true social cost. This pricing mechanism would incentivize operators to buy quieter drones and optimize their routes to minimize noise. By recognizing this bottleneck, we can avoid the mistake of assuming technology resolves all limits. True progress requires building the institutions to manage low-altitude airspace before we fill it with drones. Ultimately, low-altitude transit capacity is governed by property rights. Any attempt to expand delivery fleets would tend to collide with the legal constraints of the homeowners living underneath these flight routes. In practice, when evaluating drone logistics projects, we must look beyond flight range. We must inspect the local property rights framework that would govern route access and resolve negative externalities. If a proposal lacks a clear strategy for minimizing transaction costs with local residents, it would tend to face high legal costs, regardless of technological efficiency in this speculative system. We should analyze local airspace allocation by testing which routes would face the greatest transaction friction. This helps identify the true bottleneck of the entire delivery network in urban areas. Another application is to design automated payment platforms. Developing these practical micro-compensation systems is a necessary step to unlock drone delivery value without triggering intense local community resistance here. Furthermore, we must compare centralized zoning with decentralized bargaining. Structured auctions would tend to produce more stable route allocations than uncoordinated private negotiations can ever achieve in this contested space. We must also maintain a clear distinction between a speculative scenario and a forecast. This analysis helps us map the dynamic incentive structures, not predict any real exact flight paths. By focusing on scarcity sets the price, we can better evaluate the true value of airspace, including the hidden legal risks that unregulated flight corridors would introduce to local homeowners. The critical step is to design property frameworks that manage these externalities efficiently. Only then can we prevent low-altitude transit from triggering a chaotic commons above our local suburban streets. To find the answer, we must look past flight technology and analyze the underlying property rights that define low-altitude residential skies. The future is just incentives at scale. See you tomorrow.